Hello everyone, welcome to the course Data Analytics. Today we enter into the new topic of data analytics, that is Unit 4 Classification, which belongs to Advanced Analytical Theory and Method. In our earlier discussion, we reviewed the few analytical theory and methods such as clustering, association rule, and modeling technique like regression. I hope you understand all these methods very well. Now we plan to learn one more fundamental learning method that appears in applications related to data analytics, data mining and machine learning, named classification. In classification learning, a classifier is presented with a set of examples that are already classified, and from these examples the classifier learn to assign unseen examples. In other words, the primary task performed by the classifier is to assign class label to new observation. In Unit 4, we will learn two fundamental classification methods. First is decision tree and second is naive Bayes. To complete Unit 4, we required 3 sessions. So, as per the schedule, we will begin our first session to discuss decision tree. The ultimate goal of the decision tree is to create a model that predicts the value of target variable based on the several input variable. A decision tree is mostly suitable for classifying examples. Next, we will see the contents of the session 1. To learn decision tree algorithm, we divide this topic into 4 major parts. We begin with overview of the decision tree, in which you will learn what exactly classifier means, what is the role of supervised and unsupervised learning in the classification model. After that, we will learn the general algorithm for constructing a decision tree. Here, you will learn about basic fundamental steps for building a decision tree. Then, we will proceed to learn about the decision tree algorithm. Here, we will review the term entropy and information gain. We conclude our session with the discussion on evaluation of decision tree. So, this is the pathway for our lecture. Next, we will address the question of what exactly classification means. Before we start learning what classification means, it is necessary to know the term classifier and classification model. So, classifier means it is an algorithm that is used to map the input data to a specific category. Then the term classification model, it means the model that can predict or draw a conclusion to the input data given for training. It will predict the class or category of data. Now, classification is a type of supervised learning. That means in machine learning, classification is a supervised learning concept which basically categorizes a set of data into classes. The most common classification problems are speech recognition, face detection, handwriting recognition, and document classification. It specifies the class to which data elements belong. That is, in short, it processes or categorizing a given set of data into classes. It can perform on both structured and unstructured data. It predicts class for an input variable. That is, the process starts with predicting the class of given data points. The classes are often referred to as target, label, or categorize. There are two types of classification. First one is binomial or binary classification. It is a type of classification with two outcomes. For example, either true or false. Then multi-class. The classification with more than two classes. In multi-class classification, each sample is assigned to one and only one label or target. Okay, hope you understand what exactly the multi-class. Now it is interesting to see what exactly the classification applicable in which areas. So the examples of classification task is widely used in predicting the tumor cells as benign or malignant. Classification task can be used in classifying the credit card transactions as legitimate or fraudulent. It is also applicable for classifying the secondary structure of the protein as alpha helix or beta sheet or random coil. So these are the few areas where classification can be widely used. Every one of us should remember that the decision tree algorithm falls under the category of supervised learning. They can be used to solve both regression and classification problem. If you don't know what exactly this supervised learning, then don't worry. We will first understand it on next slide. Decision tree is based on supervised learning approach. But what is supervised learning? The data that you have collected is labeled, and so you know what input need to be mapped to what output. In short, it is used for prediction of a class label. While in unsupervised learning, the data collected has no labels and you are not sure about the output. For supervised learning algorithm, there is a need of dataset for creating a tree. Decision tree learning is one of the most widely used and practical method for inductive reasoning over supervised data. That is, it represents a procedure for classifying categorical data based on their attributes. There are two important terms associated with classification model building. One is training set and second is test data set. Let's see these two terms on next slide. Given a collection of records, that is training set, each record contains set of attribute. One of the attribute is the class, which further is used to find a model of a class attribute. The objective or goal is previously unseen record should be assigned a class as accurately as possible. A test data set is used to determine the accuracy of the model. Usually, the given data set is divided into the training data and test data set. With training set used to build the model and test set is used to validate it. Training data is used to understand how the given input variable are related to the class. And once classifier is trained accurately, then it can be used to detect whether there will be a heart disease there or not for a particular patient. Generally, in classification model, data set is divided into two parts. Test data as 20% and 80% as a trained data set. On the next slide, I will show you the example. From that, you will clearly understand what exactly this 20% and 80% means. To build one classification model, there is a need of collection of records. Each record contains set of attribute. For example, age, income, and one of the attribute is class. That label here in this case is by computer. Training set is one kind of data set. You can extract the features and train to fit model. The ultimate goal of this model is to apply the previously unseen record to predict their class. This class should be predicted as accurately as possible. Classification, the observation from the training set, is used to learn by logistic regression support vector machine known as classification model, then naive Bayes or decision tree classification, then random forest classification called as nonlinear classification model. Once they learn from the observation, they further predict the class label. Test set is used to determine the accuracy of the model. It is also used to evaluate the performance of the model using some performance metric. It is important that no observations from the training set are included in the test set. The data set shown here is to predict whether the person can buy the computer or not. This we will discuss very soon in detail. Right now, the intention behind using this example is to understand that decision tree is a supervised classification algorithm. Next, we will see what is the structure of decision tree. As the name suggests, this algorithm has a tree type structure. Decision tree is used to specify sequence of decisions and consequences for given input. The goal of the decision tree is to predict a response or output variable. Due to its flexibility and easy visualization, decision trees are commonly used for solving the problem based on classification concept. The prediction can be achieved by constructing a decision tree with a test point and branches. Okay, so this is called decision tree. Next, we will see what exactly the input and output of decision tree. For a given input X, the goal of decision tree is to predict the response or output of variable Y. Each member of the set x1, x2, xn is called an input variable. The prediction can be achieved by constructing a decision tree with test point and branches. Classification trees are used to apply to output variable that are categorical in nature. For example, yes/no kind of output. Now it is time to review some basic terms associated with decision tree such as root node, leaf node, depth of tree on next slide. Decision tree is a flowchart like tree. Internal nodes are decision or test point. Each internal node referred to as input or an attribute. The top internal node is called root node. It represents the entire population or sample, and this further gets divided into two or more homogeneous sets. Here in this case, the root node is split into the two branches with gender as a test. The right branch contains all those records with variable gender equal to male, and left branch contains all those records with variable gender equal to female. To create the depth 1, the decision tree shows here the binary tree in that each internal node has no more than two branches. The branching of node is referred to as split. When subnode split it further subnode, then it is called decision node. The depth of a node is the minimum number of steps required to reach the node from root to the leaf node. For example, node income and age have depth 1 from root node. Now you can see the 4 nodes on the bottom of the tree. So it is having depth of 2. The depth of the node is the minimum number of steps required to reach to the leaf node from the root node. Leaf node are at the end of the last branches on the tree. Nodes with no children or no further split, they represent a class label, the outcome of all the prior decision. The path from the root to the leaf node contains series of decisions made on the various internal node. The leaf node is written the class label, and in some implementation they return the probability score, that is in naive Bayes. A decision tree can be converted into set of decision rule. This example shows that females with income less than 45,000 and male 40 years old or younger are classified as people who would purchase the product. In traversing this tree, age doesn't matter for female and income doesn't matter for male. Next, we will see general algorithm for decision tree. In general, the objective of decision tree algorithm is to construct a tree from T of training set S. When all the records in training set S are related to any class C, for example, income high is equal to S of training set S is satisfactorily pure, that is more than a preset threshold, then that node is assumed as a leaf node and label C is assigned to it. In the process of constructing a decision tree, the first step is to select the most informative attribute. The entropy-based method are the common option to identify the most informative attribute. The term entropy we will discuss in detail very soon in today's session. Right now, we are discussing the criteria for constructing a decision tree. The algorithm constructs subtrees for the subset of S recursively until one of the criteria is met. First criteria is all the leaf node in the tree satisfy the minimum priority threshold. The purity of node can be described as its probability of the subsequent class. In our case, the purity of node is gender. Second criteria is the tree cannot be further split. The preset minimum purity threshold is not sufficient to split the tree further. If it is not case, then check for the minimum purity threshold is fulfilled by all the present leaf node. Third criteria is any other stopping criteria is satisfied, such as maximum depth of the tree. This is another stopping criteria is satisfied. Now we will apply all these steps to our earlier data set for constructing the classification model. Consider our data set for training purpose. We start building the decision tree by choosing age as the root of the tree. Good choice of root attribute and internal node attribute is a crucial point. Bad choice may result in another knowledge representation. So, first step in constructing decision tree is shown on next slide. In this step, we pick an attribute for division of given data. Then divide the given data into set on the basis of this attribute. We are considering age as an most informative attribute, but what is the criteria for choosing age only as root node? How do you come to know which attribute should be kept at root node? For that, see the next slide. To choose the most informative attribute as root node, one of the best method is entropy. So entropy is a common option to identify the most informative attribute, which are used by decision tree learning algorithm such as ID3 known as iterative dictomeasure, then C4.5. Once you understand clearly entropy and information gain concept, then it is very easy to learn ID3 and C4.5 learning algorithm. Now it is interesting to see that what are the two measures for root selection. Next, we want to find the most useful attribute in classifying a sample. So for root selection, there are two basics measure. First is entropy and second is information gain. Entropy is used to measure the impurity of an attribute. It is a lowest if there is at most one class present, and it is highest if the proportion of all the present classes are equal. Information gain, it is used to measure the purity of an attribute. Remember that attributes are assumed to be categorical. Next, we will see mathematical equation for both of these terms. So, entropy is the most important step in decision tree construction. So, here it is provided a class X with label X, small x is element of X. Considering the probability of X, the entropy Hx, the equation illustrates that the entropy Hx will be 0 when all the probability of X is 0 or 1. In case of classification in binary form, true or false, Hx is 0 when Px, that is the probability of X of each label X, is either 0 or 1. Suppose entropy is equal to 1, whereas entropy X will get the maximum entropy in the case when all the class label have the same probability. In case of classification in binary form, entropy is equal to 1 if all the class label have probability as 50-50. Next, we will see how to calculate the information gain. The information gain by an attribute A is defined as difference between the attribute base entropy and its conditional entropy. Equation shows the information gain by branching on attribute A. Information gain increases with an average purity of the subset. In other words, we can say information gain is the difference between information needed before splitting minus information needed after splitting. A contains the subset created after splitting S by attribute A such that S is equal to small v element of V. Here values of A is the set of all the possible values for attribute A. SV is the subset of S for which attribute A has value V. This SV is the number of element in SV and S is the number of element in S. This is the way for calculating the information gain on each attribute. Next, we will see training set for our example. A decision tree is indicating whether a customer is likely to purchase a computer. That is, it predicts whether a customer at all electronic shop is likely to purchase computer. So for that we have training data set. In our training data set there are total 14 records with attributes such as age, income, student, credit ratings, with two classes yes and no indicating whether to buy computer or not. As dataset is very small, so manually you can observe that to which age category it is labeled as student is yes, what is their credit ratings as fair or excellent and whether they buy computer. So if you manually calculate, then yes count is now 9 and no count is 5. It is only for our understanding purpose. We are also creating a decision tree for the same purpose. Now it is time to calculate the probability of buys computer for both the classes yes and no. Why we are calculating this probability? Because it is the input to the equation of entropy. Once we calculate the probability, we will put the values in equation of base entropy. We already saw that the entropy Hx will be 0 when all probability of x is 0 or 1, whereas Hx will get the maximum entropy in the case when all the class label have the same probability. In the case of classification in binary form, entropy is equal to 1 if all the class label have probability as 50. We are applying the knowledge for this equation. So after calculation, we got entropy as 0.94. Now it is time to calculate the information gain for each attribute. You know that information gain is the amount of information that gain by knowing the value of the attribute, which is the entropy of the distribution before the split minus the entropy of distribution after it. Just now we saw that the largest information gain is equivalent to the smallest entropy. So how much information a feature gives us about the class? You are now very well aware that entropy is the impurity in arbitrary collection of examples. We will now calculate the information gain for every attribute. Here it shows an example with 14 instances of sample of which yes count is 9 belongs to yes class and no count is 5 belong to no class. Out of 14 instances, the age less than equal to 30 is having only 5 instances, that is P1, P2, P8, P9 and P11. If you keenly observe, then 2 belongs to S class, that is P9 and P11. The record and 3 belongs to no class, that is P1, P2 and P8. The overall information gain is the entropy for the age with S is 2 out of 5. Similarly, information gain for age entropy with no is 3 out of 5. These values we will require further to calculate the information gain. Similarly, we are calculating the information gain for remaining age group. We are calculating this for the purpose of the amount of information needed to decide if an attribute node should not be selected as root node. Otherwise, it will represent different knowledge to our problem. We use log2 because the information is encoded in bits. Remember that the attribute with the highest information gain is always chosen as the split decision attribute for the current node while building the decision tree. Here, ES is the entropy of set S before splitting, when A is the subset created after splitted S by attribute A such that S is equal to S is split into the subset. Small v is element of V. Here A is the set of all possible values for attribute A. SV is the subset of S for which attribute A has value V. SV is the number of element in SV and S is the number of element in S. Now we will put all the calculated values in our equation 2. That is information gain for training set S with attribute age is equal to 0.94. That is the entropy we earlier calculated for the training set S. Total information gain including both class yes and no is 5 and total records are 14 for the age less than equal to 30 plus total information gain for the age between 31 to 40 plus total information gain for the age greater than 40. So we put the values as 0.97, then 0 and 0.97 in our equation. So we put the values as 0.97, 0 and 97. After calculation, we obtain the information gain with respect to our training set S and age as 0.26. Similarly, we can calculate the remaining attribute information gain. By using the same method, here we calculate the information gain. Here, if you observe, then training set S and student attribute is 0.15. For credit, it is 0.048. For income, it is 0.29. You can observe that the highest gain is given by age. So, the age attribute will come at root. So, this is shown on the next slide. Age is the most informative variable placed at root. It is further classified into 3 intermediate nodes such as younger age, that is less than 30, middle age having age between 31 to 40 and senior as greater than 40. With a single class, only S is present in our training set, that is equal to 4. So these are the purest result which further cannot be split. So leaf node present the desired output. We will carry out our test on record number P1, P2, P8, P9 and P11 can be further classified into 2 classes, that is yes and no, while only record number P13 is having single class, that is S. Test on age less than 30, that is youth. Test on student produces decision node as no, which further reached to the leaf node and thus created the class no. The customer is unlikely to buy a computer. So we omit these P1, P2 and P3 as we have seen just now that as per our decision tree they are unlikely to buy computer. Now consider another age group less than 40, that is the next internal decision node. Instead of test node as student, we will carry out test on credits, that is fair or excellent. So here we consider the age group less than 40 and test node as credit and buy computer. So record number P4, P5, 6, 10 and 14 have 2 classes, yes and no. So this node will further split it into two. The construction tree shown on the next slide. This decision tree can be further used for two purposes. First purpose, it can predict the further record inserted into the data set will correctly labeled, and another use is used that is for making the decision rule, such as if age less than 40 and credit is fair, then buy computer is yes. I hope you understand very well how to create a decision tree for a given data set. The most important task is to calculate the entropy and information gain for each node so that you can able to decide which node should be at root node. There are multiple algorithms exist to implement decision tree. Some important algorithms include ID3, that is iterative dichotomizer, then C4.5 referred as statistical classifier, and one more popular algorithm is CART, that is stand for classification and regression tree. We already discussed in brief with one example of the general algorithm for decision tree. I am quite sure that on your own you can easily understand these alternative algorithms. Next, we will see how to evaluate the decision tree. Decision tree use greedy algorithm. In that, they always choose the option that sends the best available at that moment. At each step, the algorithm select which attribute to use for splitting the remaining record. This selection may not be the best overall, but it is guaranteed to be the best at that step. This characteristic reinforces the efficiency of decision tree. However, once a bad split is taken, it is propagated through the rest of the tree. To address this problem, an ensemble technique such as random forest may randomize the splitting or even randomize data and come up with multiple tree structure. These trees can be vote for each class, and the class with the most vote is chosen as the predicted class. Next, look at the depth and nodes of the tree. Having too many layers and obtaining nodes with few members might be sign of overfitting. In overfitting, the model fits the training set well, but it performs poorly on the new samples in the testing set. The graph shows the performance of an overfit model. The x-axis represent the amount of data and y-axis represent the error. The blue curve is the training set and the red curve is the testing set. The left side of the gray vertical line shows that the model predicts well on the testing set, but on the right side, the gray line, the model performs worse and worse on the testing set as more and more unseen data is introduced. Next, we will see few advantages and disadvantages of decision tree. Decision trees are computationally inexpensive and it is easy to classify the data. The output are easy to interpret as fixed sequence of simple tests. Many decision tree algorithms are able to show the importance of each input variable. Basic measures such as information gain are provided by most of the statistical packages. Decision tree are able to handle both numerical and categorical attribute and are robust with redundant or correlated variable. Decision tree can handle categorical attribute with many distinct values such as country code for telephone numbers, decision tree can also handle variables that have non-linear effect on the outcome. So they work better than linear model. For example, linear regression and logistic regression. For highly non-linear problem, decision tree are naturally handle variable interaction. Every node in the tree depends on the preceding node in the tree. So these are the certain advantages of decision tree. Now we will see further few disadvantages of decision tree. The structure of a decision tree is sensitive to small variation in the training data. Although the dataset is the same, constructing two decision trees based on the two different subsets may result in very different trees. If a tree is too deep, then overfitting may occur because each split reduces the training data for subsequent split. Decision trees are not a good choice if the dataset contains many irrelevant variables. So these are the few disadvantages of decision tree. Next, we will see study questions. Explain the term general algorithm in decision tree. Then second question, define the following terms with suitable example of each. First is internal node, second is branch test, and third is leaf node. One more question you have to solve. Justify the statement with one suitable example that decision tree can be used for classification task. You have to solve this question and upload to our Google Classroom. Now we will summarize our today's session. Discuss decision tree is very simple but powerful learning paradigm. It is a type of classification algorithm for supervised learning. We reviewed the general algorithm for the construction of decision tree, in which you learn that we need to test all the attributes and select the one that will function as best route. Then we have discussed the evaluation for decision tree, in which the pre-pruning stop growing the tree at some point during the construction when it is determined that there is not enough data to make reliable choice. If you have any difficulty or problem in solving the assignment question, feel free to post your queries at the forum of Google Classroom. I will be happy to solve your queries. Thank you very much. Have a nice day.